A jeepney from rest accelerates uniformly over a time of 3.25 seconds and covers a distance of 15 meters. Determine the acceleration of the jeepney. Para ma-solve natin ang problem na binigay kanina sa ating lesson, sabi doon, there is a jeepney from rest. So mag-drawing muna tayo for our step number 1. Mag-drawing tayo ng jeepney, which is from rest. Ayan. And that jeepney from rest, lagyan natin ng label, no word na from rest. And that from rest, it means its initial speed is equal to 0. And according to the problem, the jeepney accelerated. Okay. And it covers a distance of 15 meters. So from here, nag-cover ito ng 15 meters na distance. Ayan. And then, let us continue the drawing. So now, from that position, the jeepney will be moved or change its position now. Swing's motion is defined as continuously change in position. So here is my drawing of my jeepney. Ayan. So, now, to cover that 15 meters, according to the problem, the time is equal to 3.25 seconds. And now, what are we going to find out is, ano nga ba ang value ng acceleration ng jeepney? So here, after our illustration of the problem, let us have the step number 2, organize data. How to organize the data? We are going to list down the 5 physical quantities involved in the kinematic equation, such as the initial speed, final speed, the acceleration, the time, and the distance. Tignan natin kung involved ito lahat sa problem na nabigay kanina sa ating lesson. Okay? So we have the initial speed. According to the problem, it is 0 because it is stated that jeepney is from rest. So I will write 0. And then for the final speed, in the problem, it is not directly involved or given. Okay, so lalagay ko dito, not involved and values not given. Hindi siya talaga kasama sa problem. Hindi nabanggit. And acceleration is missing. Involved but missing. Because that is the quantity that we are going to solve or find out. And then we have the time, which is equal to 3.25 seconds. And the distance is equal to 15 meters. Okay. Now, this data will be utilized and compare with the fourth kinematic equation. So what will be the best kinematic equations that we can use to solve this problem? Okay. So in your notes, you have these four kinematic equations, such as A equals Vf minus Vi over T. Equation number 2 equals distance equals quantity Vf plus Vi over 2 multiplied by time. Number 3, we have distance equals quantity Vf squared minus Vi squared quantity, okay, over 2a. And last equation is number 4. Distance equals initial speed or Vi times time plus acceleration times the square of time over 2. Yan. Ano ang pipiliin natin na equation dito para mahanap yung acceleration? Okay, so dito lagyan natin yung step number 3, equation. Okay, so paano natin malalaman? Okay. So, titignan nyo lang kung alin dito yung pinaka pwedeng gamitin by means of kung ang value ay involved sa kinematic equation at pwedeng gamitin. So, for example, equation number 1. Pwede kaya itong gamitin? Okay, so acceleration is involved in the problem. So, it can be used. Final speed is in this kinematic equation compared to the given in the data of the problem, VF is not involved or value is not given. So in that case, if the physical quantity is not involved or not given at the same time, it means that it cannot be used in as our working equation. So therefore, equation number 1 is not applicable to solve the problem. Okay, because VF is not involved and not values are not given. Okay, equation number 2. We have distance which is given 15 meters. VF here is present, but in the data it is not involved and not given at the same time. So therefore, we cannot utilize this equation. Equation number 3, we have distance 15 meters. Again, VF appeared here, but values not given, not involved. So therefore, we cannot use this equation even if we have VI and acceleration. Let's have the fourth equation. We have distance in the problem, 15 meters. VI which is 0. Time which is 3.25, and we have acceleration which is involved but missing, and the time which is equal to 3.25 seconds. So therefore, everything in this equation is directly involved in the problem, and the only missing or no value is the acceleration. So therefore, equation number 4 is the one that we are going to use. So we are going to write now D equals initial speed times time plus acceleration multiplied by the square of time over 2. Then substitute the values. D is equal to 15 meters. And then equals substitution for the VI which is equal to 0. Time is equal to 3.25 seconds plus what is acceleration? That is missing. So I will write letter A only. I'll just copy this because it is not given. Then multiplied by the square of time which is 3.25 seconds tapos quantity squared. Yan. Next is may over 2 pa yan. Okay. So we just substitute the values. Now let us simplify the equation. So anything that is multiplied by 0 is equal to 0. So 0 na yan. Copy what is left. So we have 15 meters equals acceleration 3.25 seconds squared is equal to 10.56 S squared. So, paano nakuha yung 10.56? You can use your scientific calculator. Yung natural display. Kung ano nakikita nyo dyan, kukopyahin nyo lang yan. Or, you just simply multiply 3.25 seconds by 3.25 seconds. So, you will get 10.56 S squared over 2. And then, you can cross-multiply 2 to 15 meters. So, we have 30 meters here. So, we have a more simplified equation, which is A equals 10.56 S squared. And then, since acceleration is the one that we are going to solve, we can now get the acceleration by dividing both sides by 10.56 s squared and 10.56 s squared. So what we can do is to cancel 10.56 s squared in the right side of the equation, and what is left is the symbol acceleration. 30 meters divided by 10.56 s squared will give you 2.86 meters per second squared. So, paano nakuha yung meters per second squared? Nanggaling siya sa meter sa taas, tapos yung s squared yung nasa baba. So, this is the acceleration of the jeepney. So, 2.86 meters per second squared is, isipin nyo, kada square of time, ang bilis, pagbabago ng bilis ng isang sasakyan ay nasa higit kumulang 2.86 meters. So, hindi pa siya ganun talaga kabilis ang arangkada niya. So, that is how we solve the problem using the kinematic equation. Okay? So, that's all. And for your output, I need your personal notes about this problem solving. Okay?